So my name is Elise Jeffery. I'm the Program Leader for Fire and Biodiversity with the City of Hobart.
And how did you get that job?
I'm not really sure, to be honest. I started as a Program Officer 2.5 years ago with the City and now a Program Leader. Probably my background is actually biodiversity rather than fire, but I've always had an involvement, I guess, in fire, either through firefighting or through fuel reduction burns for ecological purposes and things like that. So I guess my role at the City of Hobart manages an operational team. So we have a crew of 7 people that manage our bushland reserves. So the City of Hobart manages 4,600 hectares of bushland, either in the City of Hobart or in adjoining municipalities. So we've got a little bit of land in Glenorchy and Kingborough. So we've got a team of 7 who pretty much manage that on a day-to-day basis, looking at weed management and fire management.
So can you tell me just a little bit about where we are?
So we're in Bicentennial Park and we're actually standing on one of our fuel breaks that we've implemented in the City of Hobart. So new fuel break guidelines came out in 2016 from the Tasmanian Fire Service, and the City embarked upon a program of implementing those fuel break guidelines through our bushland reserves. So we've got over 800 neighbours who have a fuel break on their back doorstep that's in a bushland reserve, and so the fuel break was implemented to provide the residential dwellings with a BAL protection level of 29. So it's kind of like a retrospective defendable space within public land that's been provided. So Bicentennial Park was actually one of the first ones that we did in dry eucalypt woodland, and then we've moved through the city and now we're up in fern tree at the moment implementing them in wet forest. So it's quite a different environment up there.
So thinking about Bicentennial Park, so what are the kind of the main challenges of managing bushfire here?
The main challenge for Bicentennial Park is probably the fact that it's kind of like landlocked by residences really. So it's got incredibly steep terrain, which you can kind of see behind me, and then as soon as the land sort of starts to flatten out, you just got a bank of houses. So the land that we have to manage from a fire point of view is quite steep and rugged, and then it's just surrounded by dwellings. So that's probably our greatest issue. Also, we have a gully that runs through here that contains wet forest. So wet forest can historically can't really be burnt. The only time it would really be dry enough to burn would be in a January month when it'd be just too dry and it would just take off. And then other months of the year when we traditionally do our hazard reduction burning, such as autumn and spring, it's just too damp to burn. So that provides a real risk kind of right in the guts of Bicentennial Park. So we've sort of got to manage all of the edges quite well to be able to manage and contain that risk. So across the City of Hobart, our 3, I guess, programs within the fire program are hazard reduction burning, fuel breaks, and then fire trail management. So the hazard reduction burning across all of our bushland reserves in dry eucalypt forest and in grassland ecosystems. Then we have our fuel breaks, so those are located next to assets, so they're along our boundaries where we have residential dwellings or civil infrastructure that we need to protect. And then we have fire trails that go through and around our bushland reserves that provide us the opportunity for the hazard reduction burning, but also access in case of a wildfire. So there are 3 main programs that we implement citywide to reduce the risk of fire in the city. So the width of the fuel break is based upon that BAL assessment. So that looks at the location of the dwelling and provides like a 29 BAL assessment defendable space. So it depends upon the slope, the vegetation type and the aspect to how wide this break should be. This was one of the first sort of fuel breaks we put in Bicentennial Park was this one. We probably went a little bit too hard on this, so it's probably a little bit too, there's a lot of canopy trees and so it's probably a little bit too open. And probably something that we'll look at restoring in the future. So we'll allow those to come up and restore part of the canopy back in the fuel break.
So what's the thinking around that? Why do you want some canopy trees?
So I guess after the fuel break has been kind of put in, there's kind of been some more recent research that's come out of CSIRO in particular, suggesting that canopy trees actually provide some benefit for residences in case of wildfire. So they actually provide some protection against radiant heat from an oncoming bushfire. They can capture embers areas that would otherwise land on the house, so they can capture them in the tree canopy and just disperse some of the hot wind and heat that comes from that bushfire. So we're looking at trying to get those back into our fuel breaks. So these fuel breaks are implemented, so they're established, and then we come back on an annual basis and they're maintained before summer. So before December 1st every year, the crews will come through and pick up some of the fallen timber, make sure the grass and everything is brush cut down to less than 100 mil, and just make sure it meets the standard every summer. The neighbours seem to be generally positive about the fuel breaks. I think they seem to be fairly conscious of the fire risk, but they enjoy living next to bushland, but they are also accept, I guess, that there's some fire risk inherent in that. Probably the biggest issue that we have is, I guess, that maybe people don't recognise that the fuel break is only effective if they do something similar on their own property. So the fuel break is meant to be from the dwelling out, and so we've done the part, I guess, from their boundary fence out, but it's from the boundary fence into their dwelling that needs to be maintained to that standard. Otherwise, it's going to be largely ineffective. So that's probably our biggest issue. So research methods that we use, I guess, for planning our hazard reduction burning is looking at things like slope and aspect, vegetation type, access points, water points, and lighting patterns. I suppose that's all what it's about in terms of where you would light and how the fire will behave through that particular unit. So there's a fair bit of pre-planning that goes into a hazard reduction burn from that point of view. We also utilise statewide databases such as NVA, looking for threatened flora and threatened fauna species, so looking at any survey results for those. So we need to obtain permits if we're going to be working in any areas that have any threatened species. We may need to change our burn plan accordingly compared to what they find. We also have to do an Aboriginal heritage survey, so that can just be a desktop exercise depending on where the location might be. The Aboriginal Heritage Tasmania might have, additional requirements that we might have to put on. Most of the time we don't have things like ground disturbance associated with our fuel breaks. We're using existing tracks and trails around the boundary and there's no machinery involved, so it's usually not too much of an issue. We've just implemented a new program, I guess, at the moment, looking at vegetation quality. So all of the vegetation communities in Tasmania are mapped on TasVeg, but that was largely a desktop exercise and sort of just a whole conglomerate of different surveys from forestry and mining and other industries, all just kind of put together into this layer. So there's not a lot of accuracy in particular about ground truthing. So for us, we need to know where particular vegetation communities are, where wet forest is compared to dry forest, so that we know if it's actually going to burn or not. And then from a biodiversity point of view, we're actually trying to work out, well, what is the vegetation quality and what do we want as an outcome from that? So one of the reasons we do that now is just to try and understand what other work we can do and what impact fire might have on the vegetation quality of that unit. So we're doing that pre-burn. Otherwise, it'll probably take, for most of these communities, 20 to 25 years before they get back to that mature state. So that's kind of the process, I suppose, that we're going through at the moment to try and understand a bit more what the management unit looks like before we put fire into it, and then how we manage that in the longer term so that we maintain the vegetation quality that we have here in the city of Hobart, because it's pretty precious. Most of the bushland reserves we have here are of exceptional quality. Like to be such high quality veg right next to a city is probably pretty exceptional. And so we need to be able to maintain that. And that's what we're here for. We're fire and biodiversity. We're here to maintain those aspects. And so we need to understand what our outcomes are. So that's the process that we're going through at the moment. I guess one of the biggest challenges we have for fire management moving forward is climate change and how that's going to change how we manage fire in our bushland reserves. So I guess one of the things that they talk about is that window of opportunity for hazard reduction burning and how that's going to change with climate. So we've had a lot of dry seasons where we've just been waiting in autumn for the rain to come and then waiting for it to be at the right optimal sort of moisture content to be able to burn without it then heading straight into winter and having it too wet to burn. So yeah, that's definitely an issue. And we're definitely seeing that there's some parts that have been burnt that's taking so much longer to recover. So Normally you look at cyclic times for grassy woodlands somewhere between 10 to 25 years on a cycle that you come back to burn them. And some we're coming back to, and it's just like they still don't have really enough, they have enough fuel to carry fire. But if we actually burnt them, we'd be doing probably significant damage to the ecosystem because it hasn't really recovered from the last burn that it's had because of being in a decade or drought. So that's probably one of the reasons why the fuel breaks are probably so important. They're close to the assets, so they're protecting what we need to protect most, and they're kind of always there, and they can always be maintained irrespective of how the climate changes. Whereas the hazard reduction burning is something that we're just really not sure about how that's going to look into the future.